Today is December 22nd, 2015. I'm Joe McMaster, and as part of MIT's Infinite History Project, I'm speaking with Dr. Martin Schmidt, an MIT alumnus, a member of the faculty since 1988, and MIT's current provost. Professor Schmidt has worn many hats at MIT, from his teaching and research as a faculty member in the Department of Electrical Engineering and Computer Science, to serving as the director of MIT's Microsystems Technology Laboratories, Associate Provost, a senior administration officer responsible for industrial interactions, the leader of numerous institute initiatives and task forces, co-chair of the board of directors of edX, and co-founder of many successful startups, to name just a few. Professor Schmidt received his bachelor's degree from the Rensselaer Polytechnic Institute and his SM and PhD degrees from MIT. His work and contributions have been recognized with numerous MIT national and international awards. Welcome, and thanks for speaking with us.
Thank you for having me.
So I wanted to start actually just talking about some of your work, your research work, and particularly, as I understand it, was sort of focusing on the micro and nanoscale. And I'm wondering if you can tell me a little bit about that and what attracted you to that scale, what attracted you to that kind of work?
Yeah, sure. I'd be happy to answer that question. I would say, I've always been fascinated by how things are made, and I've always enjoyed, as a kid growing up and throughout the years, building things. And when I came to graduate school at MIT, I got very intrigued with, at the time, what was called VLSI, or very large scale integration, which is basically the way in which computer chips are being made and the design of computer chips. And I was just fascinated with the processes people were using, and this was in the early 80s, the processes people were using to make these chips. So that started my journey, which was to basically learn how is it that these things are made. After working on that for a while as part of my master's degree, what I came to realize was that there was this emergent field that people were pursuing, which became entitled MEMS, for micro-electromechanical systems. And what that field does is it takes the methods of manufacturing computer chips at the micro and nano scale, and it applies them in different areas. So using it to build miniature mechanical devices, for example, or miniature photonic devices, or miniature chemical or biological devices. And I just found that for somebody who likes to build things, the ability to build an entirely new class of things by leveraging miniaturization methods just was fascinating to me, has been part of my research journey.
So where do these things show up, MEMS? Where do they show up sort of in everyday use that people might be familiar with?
Yeah, it's a great question. So the field really got launched in some respects in 1980. And what happened at that time was the federal government mandated emission standards in vehicles. And in order for vehicle manufacturers to be able to meet those emission standards that were mandated by the federal government, they needed a way to measure the engine. And it turned out that one thing you needed to measure about the engine was the amount of airflow into the engine in order to control it. And this MEMS technology was one of the ways in which you could make that measurement, making a device with this. And so the automotive industry invested in this technology and was able to demonstrate this sort of sensor to be used in a vehicle. And sort of overnight, you went from nothing being done in this field to the entire automotive industry using these sensors in the control of engines. And that catalyzed follow-on things. So after that, people started realizing, well, we can use these things to detect vibrations and crashes. And so these sensors got deployed for crash detection in airbag systems. And then the thing that really kicked this off is really the explosion of use of mobile devices. So today, your iPhone might have 3 or 4 MEMS microphones in it. It's got a gyroscope, an accelerometer. It might have an altimeter. It might have a pressure sensor. And most of those devices are used with this technology. So the field has just sort of seen this rapid expansion as these applications emerge that would leverage the ability to make a very small sensing device that operated with very low power. And so mobile is the natural connection there.
So you say you were someone that liked to build stuff as a kid. What kind of stuff did you do as a kid, and then how does that translate? Because at the micro scale, I mean, it's obviously you can't get your fingers on something of that scale necessarily, or into it. I mean, it's a different kind of building, I guess.
Yeah. Well, I mean, most of my interest as a kid were mechanical things. So the classic things that somebody in my generation would do, erector sets and, things like that. Going on to sort of rebuild car engines in high school and building furniture. And I think what appealed to me about this field is these were, growing up, it was always an interest in mechanical devices. Even though I'm an electrical engineer, the integrated circuits are fundamentally electrical devices, but all of a sudden when presented with an opportunity to make mechanical devices with this new technology, it just sort of scratched an itch that I found very interesting.
Right. So is that, as we mentioned in the introduction, you became a member of the faculty in '88, but you actually came here, as you just said, as a student in '81, I think?
That's right.
So is that what you came here to work on, or did you know at the time what you wanted to work on?
Not entirely. I did my undergraduate in electrical engineering, and I would say I was sort of a general electrical engineer. I had a lot of different interests, and I think my first year here in graduate school, I spent a year as a teaching assistant teaching an electrical engineering laboratory and sort of sampled a lot of different courses and stumbled across literally this whole field of VLSI, and that sort of took me on my journey.
So so where did you, at the time when you embarked on that journey, did you have a goal in mind, or did you sort of think, well, I'll see where this goes? And
no goal. I mean, when I completed when I was completing my bachelor's degree, I was pretty convinced I wanted to go to industry. It just seemed like that was where the exciting things were happening, where you can make stuff. Interviewed with a lot of companies and put in one graduate school application to MIT, and basically found that what I was going to be allowed to do in industry with a bachelor's degree just wasn't really interesting enough to me. And so through some stroke of luck, I was admitted to MIT and basically decided to come here. And decided to come here with the full intent of getting a master's degree, which would give me the credentials to do the things that would be really interesting to do in industry, finish the master's degree, and then realized that I really liked what I was doing and stayed on for the PhD with the full intent that at that point I would go out and do industry. But then when I graduated with my PhD, was offered a job here and at MIT, and it was clear that that was going to be my best opportunity. And so there's always been this interest in pursuing industrial opportunities, and I think the way I ultimately satisfied that interest was by making sure that our research was closely coupled to industry and focusing a lot on making sure the work we did on campus translated to industry in some fashion.
So what made you then decide, okay, well, I'll try to incorporate the industry, but primarily be in an academic institution?
I think it's the freedom that academia affords you to really pursue your own interests. And certainly at the time that I was graduating from school, the career path was go to work for a large company or a medium-sized company. And so academia in some respects offered a person like me the opportunity to do whatever I wanted to, as long as my department head let me do it, and as long as I could find the resources to do it, and I could find students that wanted to do the work. And all of those worked out. Today, it's interesting if you think about it. There's a lot more opportunities for our graduates to pursue their own interests through things like startups. And so I don't know where I would have gone where I graduated in this era, but I think for me at the time, academia presented all the right opportunities.
So was teaching on your radar at the time as an interest? Or?
I think I've always had an interest in teaching. And so in some respects, being able to teach while doing all these other things was just kind of a nice opportunity. But also one of the things that I found as I became a faculty member and started teaching was that you start to appreciate how teaching really reinforces your understanding of the material. And I think the epiphany for me as a young faculty member was this notion that when you have all these bright students in front of you and you're trying to express a concept that you understand one direction, they may think of it in a completely different way. And your challenge then is to sort of connect those dots for them in the way they want to think about the problem and the solution. And that really strengthens your understanding of it. And that pays dividends. So when I have to explain a complex phenomena to a student, and I learn more about that by working with them, that allows me to apply that enhanced knowledge in the things I do. So there's this notion that I think is the basis of research universities, which is the integration of research and teaching, I think is a really powerful concept. And I'm not sure people fully appreciate that, because you always see people thinking about, well, we'll just do teaching in this sort of an institution, we'll just do research at this institution, this type of an institution. I think when you look at higher ed research intensive universities in the US, the proof is in the pudding. Our research universities in the US are the envy of the world. And I really do believe that it has a lot to do with this knitting together of teaching and research.
Yeah, yeah. And you mentioned you've found lots of ways to incorporate contacts with industry in your work here. Maybe you can tell me a little bit about that.
Sure. My PhD advisor used to always like to say, everybody can do good work, and a way of differentiating your work is by choosing really important and good problems. And I think some of what the engagement that MIT historically has with industry allows us to do is to think about what are really important problems. And you see that across the board, in things like our energy initiative, whereby engaging with energy companies, it gives the faculty a much deeper understanding of what's an important problem to work on. And I think that was what made engaging industry early on in my career very compelling to me, because you could go visit with them, understand some of the problems they were struggling with, and then you could think about, how could I make a difference for them? And it's not going to make a difference in the next quarter, and it's not going to make a difference in their profits and losses in the next year, but it sets me on a process of developing some new knowledge that will make a difference for them 5, 6 years from now. And that's, I think, the value that you get out of industry.
I mean, MIT has a very long and deep relationship with industry, as I understand it, going way back. Is that unusual? And how do you see that relationship? I mean, is it unusual for an institute like this or institution like this?
So the most important footnote is to recognize that in some respects, I've spent my entire adult life at MIT. So if you're asking how we're unusual, I've got a limited perspective on that. But having said that, I think just purely by the numbers, MIT's engagement with industry as measured in terms of the amount of our research sponsorship that's sponsored by industry makes MIT unique in that regard. So I would say, strictly by the numbers, the percentage of research we do engaged with industry is probably the largest of any of our peers, and it's our history. When MIT was created, it was really founded on a new model for a higher education institution, and there was this recognition that being embedded within industry is really important. In fact, there's some great articles written at the time of the incorporation of MIT that describe the importance of being embedded around industries. And in fact, MIT's move to Cambridge 100 years ago was really a representative of that, moving to a part of Boston and Cambridge where really the Industrial Revolution was occurring. Help promote those same connections. And it's the same thing we see today with the explosion of interests of companies to be in Kendall Square and the synergies we get from that.
Yeah, which is extraordinary, yeah. So you have also been engaged in your own sort of entrepreneurial and consulting activities, as I understand it. Maybe you can tell us a little bit about some of the, you've done a number of startups and things, and how that came about, or how those have come about.
Well, I think it's been a natural evolution, and I think it's also been a reflective of the evolution in how industry works in the U.S. So, as I mentioned earlier, when I was a young faculty member here, we were working with companies like General Motors, we were working with Ford, working with Honeywell, and Bosch Corporation, and we would work on problems that we knew were important to them. And if we were successful in that work, we would transfer that technology to them. And so there are instances where a student's thesis work ended up in a product that Ford or GM would sell. But over time, the pathways for technology to leave MIT have evolved. And some of this has to do with the change in the structure of U.S. industry, where there's less of these sort of R&D labs like the original Bell Labs or RCA Labs or other places which were often the intermediaries between the campus research and the application into a particular product. And as those types of laboratories started to disappear, increasingly you saw the transfer of our technology either directly to medium-sized companies or perhaps through a startup. So where my research was always about trying to work on things that could have a translation opportunity in 5 or 10 years out, over time the translation opportunities were more logically through startups. And so it was just a natural progression of moving from transferring a technology to a Motorola to transferring a technology through a startup to ultimately a customer.
Mm-hmm. And what kinds of startups have you been involved with?
We started out in the space of in biomedical types of devices. So some of the startups were involved in the manipulation of blood and rare cells, isolating rare cells from blood in order to diagnose diseases. So that was an early stage, and it was at a period of time when we were working on an emergent field called microfluidics, which is basically using these miniature devices to manipulate fluids. And there was a lot of, the benefit of that is that you could make devices that were the size of biological cells, so it allowed you to individually handle them. So we did a couple of startups in that domain. But all of them have sort of tracked my research agenda. So we went from looking at this miniaturization capability applied to biology. We then transitioned to look at this miniaturization capability applied to energy generation devices. So we started working on miniature turbine engines and miniature fuel cells. And in the case of the latter, in the case of fuel cells, we were involved in transferring the technology there. And then most recently, we've been exploring new ways to manufacture devices at the micro and nano scale. And so, for example, we worked very hard on some new ways of printing micro and nanoscale devices, and that's led to the most recent spin-out of our lab, which is a company that's developing actually equipment for manufacturing flexible displays.
Interesting, yeah. So wide variety of stuff, it sounds like, yeah.
All anchored in the exploitation of this micro and nanotechnology.
Sure, yeah. So at some point, you made a transition there from, I mean, you're still doing these things, I know, but from, the more straight academic route of just, the teaching and research into the more administrative realm.
Mm-hmm.
And how did you make that transition? Where did that occur? And
well, so I'd say it's more an evolution than a translation or an evolution rather than a translation, in the sense that, there's a point in time in my career when the laboratory that I was working in, the leadership of that laboratory asked me to take on some responsibilities in making sure that the laboratory ran smoothly. I have a very vested interest in that because I'm highly reliant on the success of this laboratory, so you start getting engaged through that. So over the course of the years, my responsibilities to help make sure that lab ran smoothly grew to the point where I became the director of the laboratory and ran it for about 6 or 7 years, I think. So I think it's sort of out of enlightened self-interest, in the sense that, obviously my success is tied to the success of these facilities, so I need to do my part, but also it also is about sort of building the ecosystem, so that if I can help create a facility that helps others, then those others are going to be successful, and their success will sort of catalyze new successes for me. So there's a lot of self-interest embedded in there, but also I think over time, I feel as though MIT has really presented me with tremendous opportunities, and there's a certain sense of, I wouldn't even call it obligation, but a sense of, geez, now it's my chance to really make a contribution that helps the next generation of students. So I think your mind shifts a little bit in terms of this enlightened self-interest to sort of feeling like this is a greater good, which is, contributing to the Institute. So, when presented with opportunities to where I felt like, or I could do that, I was happy to take those on. And eventually you tire of them. I think when I was running the Microsystems lab, my experience was that at about 5 or 6 years in, I started realizing that the problems I was solving were problems that I solved 5 years ago, but in a different form. And so my learning was starting to plateau, and I sort of realized that this was a perfect opportunity for somebody else to come in and learn all these new things. So I think some of these things, for me at least, are things you do for 5 or 6 or 7 years until you feel like you're sort of plateauing in your learning, and then there's an opportunity for somebody else to do it. So I did the Associate Provost job for about that length of time, and then stepped into the Provost role about 2 years ago.
Mm-hmm. And so as Associate Provost, what's really involved, and how did that unfold?
So my role as Associate Provost, the job I stepped into was one which is principally to manage space and to work closely with the Executive Vice President of the Institute in thinking about our capital planning and how we're going to evolve the campus. It's an unusual role for an academic to take, because at a lot of universities that job is filled by a staff member. And I think at MIT there's a strong sense of the importance of faculty governance in everything that the Institute does. So my theory is that the role that I assumed, which had been in place for a number of years, was really a result of this community's sense that they want faculty involved in these things, even though at other places they might be run by staff members. So that was my job, was basically assign space, make sure space was being managed efficiently, approve renovations, and I had the budget for that. And then, as I said, work with the Executive Vice President in terms of the overall campus plan. Over time, as I sort of became more comfortable with that job, I took on other responsibilities, most notably towards the end of my time as Associate Provost, was sort of trying to organize more succinctly our industrial engagements. So having worked closely with industry and worked with a lot of the offices at MIT that face industry, I recognized this opportunity to organize ourselves a little bit more effectively. So I got involved with that as well.
So, and as I understand it, one of the more well, challenging things that MIT and all of us faced when you were Associate Provost was, of course, the economic downturn. You were a big part of the team, the task force that was dealing with that. Is that right?
That's right. That's right. In 2008, we saw basically a global meltdown, and it impacted MIT very directly, in the sense that we saw our endowment decline precipitously, and where a decent fraction of our operating budget is based on the return on the endowment. If the endowment goes down, it has a huge impact on our operating budget. Credit goes to Susan Hockfield and Raphael Reif and Terry Stone at the time, who, as President, Provost, and EVP, recognized that we really need to engage the community. I mean, a lot of universities at the time were just sort of saying, okay, well, we're going to freeze salaries, we're going to lay all these people off. I think we approached it in what I think is the MIT way, which is we created a task force. I was fortunate enough to be asked to co-chair it with Israel Ruiz and Steve Lerman. In the middle of that, Steve went off to become provost at George Washington, so Israel and I sort of completed the task. But what we did was really put together identified areas where we thought there were opportunities to make adjustments to our budgets, and but we put together basically working groups for each of those areas, be they in the area of facilities or in the area of research or in the area of education, and put together teams of faculty, staff, and students, and asked them to come up with ideas and present to us ideas that could either create efficiencies or new revenues or other sorts of things that would allow us to get through this budgetary crisis. So it was a very deliberate process. It took time, but I think in the end what we ended up with was a set of recommendations which we could act on, which had the community support. And there are other areas where the community was quite clear that they didn't want us to go in that direction. So I think it was a good process. It helped. It didn't solve all of the issues associated with the financial crisis, but it helped, and I think it had a additional benefit, because I think it gave the community a sense that they were able to be part of solving this significant challenge. We were aided by the fact that we were in a really good financial position. We had, in the previous years, the administration had worked hard to solidify the financial foundation of the Institute. And so I think we weathered that storm pretty well for a lot of reasons, but the task force certainly helped.
Right. Um, what thinking about some of the other sort of initiatives you've been involved in, um, um, that being a big one, and you mentioned the industrial interactions as being another sort of initiative. You touched on the climate change initiative as well, which I guess is a ongoing but somewhat more recent. What's been your involvement there?
So, last year, a group of students approached President Reif and asked him to divest of fossil fuels from the endowment. And the president basically said that he felt like he wanted a more MIT solution. Maybe that was part of the solution, but simply divesting when an institution like MIT could actually do a lot, he wanted more ideas. So what he asked myself, Maria Zuber, Susan Solomon, and Bob Armstrong to do was to put together a group to basically convene the community, have a conversation about all the various things the Institute could do in response to the climate challenge, and come up with a set of recommendations. So I was one of the group of 4 that helped launch that committee. In fairness, I have to say that Maria Zuber really, at the end, shouldered much of the leadership on that. It's an area where she has great domain expertise, and so she really gets much, if not all, the credit for the output of that. But it was really an effort to bring together, the faculty leadership in the important areas that were Susan Solomon and Bob Armstrong, along with the academic leadership of myself and Maria. And as you know, we got a set of recommendations from the committee. Some of them we're acting on, some we aren't. And but I think it's the process. I think was a good process. There was a period of comment where we gathered a lot more input, and I think most people are very excited about the trajectory it's putting us on to try and work on this problem.
Yeah, what are some of the steps or ideas that have come forward from that?
Well, I think there's a couple of things. One is that we felt strongly about was rather than divest ourselves of industries that are in the fossil fuel sector, what we really want to do is work with these industries to work on solutions that solve our problems. And so I think that where a lot of universities might sort of run away from that problem, I think MIT's approach is run to it. And so what we're really trying to do is engage these companies. I mean, our students graduate and go on to work at these companies, and they're as passionate about solving these problems as anyone. And so I think what we're focused on really is trying to figure out how we can work with industries, big and small, and governments to really come up with solutions to the energy problems we're facing.
Yeah, I mean, it's not an easy situation, probably. I mean, because I know there's been you see students outside of the president's office or up in the hallways there, camping out, saying, "Gee, we should divest." And,
yeah.
And how do you sort of balance these competing agendas, really?
Right. Well, I think in the end, what we came forward with our plan is a plan that I think reflects a broad-based view of the community. There are students, faculty, and staff who feel very passionately about, for example, divestment. And while we greatly respect the passion and their views on this, we didn't think it was the right solution for MIT. And so I think there's certain areas where we disagree. But I have to say that the conversation has been extremely civil, very respectful. I think we agree on a lot of things. We disagree on certain things, and we just want to try and move this discussion forward. But at the end of the day, the students in particular who feel very strongly about divestment, as I said, we really very much respect their views. We just don't agree with them. But with their passion towards this is laudable. And in a lot of respects, I think it's important to recognize that we have a climate action plan today that was catalyzed by their actions. And so I think while they may not feel this way, I think they ought to feel some sense of accomplishment of catalyzing the Institute towards action.
Yeah, interesting, yeah. Another sort of important initiative that you're involved in is the MIT 2030
Mm-hmm.
initiative. Maybe you can tell us about that. I mean, what that is and what the goals are. And
Right, right. So, and some of this work predates my role both as Associate Provost but now as Provost. But the way I would characterize it is that the Institute has grown tremendously, both physically but also I think in stature. And one of the sort of defining moments in some respects for me was we went through an accreditation process in, I think it was 2008 or 2009. And the accreditation, which was actually chaired by the then president of Stanford, John Hennessy, gave us great reviews in terms of their assessment of the Institute. But President Hennessy at the time made a statement that was quite galvanizing for me, which is he said, you're an extraordinary institution, but in many ways you don't look like it. And what he was really reflecting on was the challenging state of our physical infrastructure. So what that simply means is that we have an aging campus, and it's a campus which has been underinvested in some respects. We went through eras where we built lots of buildings, but we didn't necessarily invest what we needed to sustain the buildings we had. And that's not meant to be critical of previous generations of leadership of the Institute, because look at where we are. We're in a remarkable place. But it's to say that now's the time to get at that. And so MIT 2030 to me is as much an exercise in the same way that we went through with the budgeting planning process. It's an exercise to galvanize the community and get them focused on a plan that allows us to grow as we need to grow, but also allows us to invest thoughtfully in the refreshing of our campus. And so it's 2030 is a living plan that sort of says where are we going over the next decade or more, and what sorts of new buildings will we need, and what sorts of existing buildings are we going to invest in to improve. And let's make sure that as we think about the financial future of the Institute, that we're baking into our budget the resources to make sure that 20, 30, 40 years from now that people can look at this campus and say, this is a world-class campus, both in standing but in its physical infrastructure.
So what's transpired since then? I mean, obviously it sounds like renovations and some new buildings and
right.
What's on the horizon.
So the process with 2030 that we went through was we asked all the academic leadership, the school deans and others, to say, where are you going? What is your school going to look like in 10, 20, and 30 years? And then what are the physical assets you need to get there? And what are the deficiencies of the assets you have? And so we went through a process of that. And we were able to kind of generate a list of these are the things that are really holding back the school, or which will hold back the school in the future if they're not addressed. And some of them are things like a department which sits in a building which is in such difficult condition that they really cannot productively conduct their work. Well, we ought to fix that building. In other areas, nanotechnology is a good example. We have an infrastructure that was created 35 years ago, which is at end of life. And so we need to create the next generation of nano facility. So looking at all those needs, prioritizing them, and then putting in place a plan to address each one of those. And in some instances, it's fixing an existing building. In other instances, it's tearing down the building and creating a new one, and then laying in the financial structure around that. So for example, the Institute pursued the so-called century bonds. So we floated several bonds that provide us with some of the financing we need to do this. And fundraising is another key element of this, is raising resources through philanthropy that allow us to refresh the campus. So it's really about a plan.
It's interesting because 100 years ago, and obviously they built the main group buildings, which are still with us.
Mm-hmm.
And have weathered 100 years now.
Right, the bones are good, but there's pieces that need fixing. And so, we're about to open up Building 2 in about a month or so, after a complete comprehensive renovation. And, the physical structure itself, great shape, but the electrical systems, the heating and ventilation systems, the plumbing systems, the windows, all needed addressing. And so I think it's going to be very exciting, because when you go into building 2 in a month, you're going to see what a 100-year-old building looks like and how it can be designed to be good for the next 100 years. And that's the sort of thing we need to do, is we need to take these robust buildings and refresh them so that the next 100 years will be as good as the last 100.
Are we still building for 100 years? In current new buildings, I don't know, Nano or others that are recent buildings on campus?
Yeah, I think, so I'm not an architect, so I don't know that I could authoritatively comment on that, but I think the structures we're building could last that length of time. We do know that over the course of 100 years, a building goes through a lot of different lives. So some of the buildings we're building today for one purpose may 30 years from now be deployed for a completely different purpose. But the physical structure, I think, could last that long.
Yeah, it's interesting. MIT has a great history of repurposing buildings too.
Absolutely.
So there's old factory buildings and all kinds of stuff.
Yeah. And I think one of the exciting projects that, we're pursuing right now is looking at whether or not we can take what had been a storage facility for more than 100 years, the Metropolitan Storage Warehouse, and see if we can't convert it into a undergraduate residence. And it's an exciting project. We're still working on it, but if we can succeed in designing a building that we're convinced will work for that purpose, I think it'll be an exciting transformation of 100-year-old building.
Yeah, that's an iconic one. I'm not quite sure well, I know you're not an architect, but how would you transform that building? Because it's got very sort of small windows and probably very thick walls, being fireproof, allegedly fireproof.
Right. So the point there is that it's a very robust building, but you're right, it has very small windows. So the architectural challenge is to figure out how you bring light into the building, and the current designs are exploring basically the development of what they call light wells, or you can think of it as courtyards, but basically interior spaces that sort of bring the light in. So far it looks pretty promising, but we'll keep working on it.
Yeah, well, it's a good MIT challenge. In terms of the community that surrounds us, obviously, is this amazing hub of innovation, and one of the things you were involved in was the production in the innovation economy study. What was that about, and where has that led?
Yeah. Well, that's a great question. So, sort of iconically, the way you could think about that is that there's a famous quote by a politician whose name I forget, or maybe I choose to forget, that it was an economist who basically made the statement, computer chips or potato chips, I don't care, or something to that effect. And it was at a time when people were wringing their hands worrying that the computer chip industry, which had most of its roots in the US, had left the country. And there was a sense that the loss of that industry was a loss that was going to impact future economic growth. And said another way, the question that the production and the innovation economy study set out to try and answer was, is it important to have production ecosystems in a nation in order for that nation to continue to innovate and to get the economic benefit of innovation? And so we looked at that problem. We said, how important is it to the creation of innovative new products and ideas? How important is it to be in a production ecosystem? Have factories, have places where things are made near where you are. And the example that's often held up as an example of it not being important is Apple, because Apple is a company that no one would dispute invents great, innovative new products. And those products are all made outside of the United States, and they're not made by Apple. They're made by people that Apple contracts with. And so if Apple can do it, why can't everybody else? And that's what we looked at in the production and the innovation economy study. And basically the conclusion we came to after looking at this from a lot of different lenses is that there's lots of tangible evidence that to accelerate the translation of ideas to impact you can do that faster if you have access to these production ecosystems. And the simplest way to think about it is that if I'm going to design, and let's use a field that I work in, which is micro and nanotechnology, if I want to build a new micro or nano device, my design of that device is greatly enhanced by an understanding of how it's going to be built. So I need to design it for production. And I get a better sense of how that is done by being nearby where those things are built. And it's not just that I have a shorter drive to go see how they're built, but in addition to that, I'm surrounded by people that are building it. And those people I interact with and exchange ideas with. So it's being in this ecosystem that really translates ideas faster. And so the production and the innovation economy study, or the PI study, we like to call it, really looked at that and came forward with lots of examples of why it is that these sort of production ecosystems are important. And that informs our thinking about the importance of Kendall Square, which is having industries that know how to produce these things. And in this region, we think is going to be critical to MIT's continued success at translating ideas to impact.
So how does that play out? You know, I mean, in what ways is it critical? How will it help MIT?
Well, if you think fundamentally, MIT's greatest contribution is the translation of innovative new ideas to impact, helping humans, helping society, then the faster we can move those ideas out and the more effective we are at doing that, the better. And in a lot of simple ways, being able, it's, you know, if I think of a faculty member who comes up with an idea for a device or a medicine or a pharmaceutical, being able to work closely with an industry that's going to produce it and being able to work closely with a production facility that's, you know, maybe an hour's drive away or less is going to make that happen faster. And it's going to you know, create that translation opportunity with a much higher probability of success.
So I mean, in terms of the study and your thinking about these things, is Apple sort of an outlier, or I mean, clearly there's a continuum, I suppose, of this?
Yeah. So my view on Apple is there's two things going on there. One is Apple works in a space where they're able to leverage an industry that has been able to standardize things. So if you think about computer chips, the process for making computer chips and the process for designing them has been standardized to the point where I can have what's called a fabless IC company that can design something and then send it to a foundry to be made. The same could be true for electronics, could be said true for electronic subassembly. So the fact that I can get together a bunch of chips and devices and displays and have them assembled by a contract manufacturer. So that ecosystem has been created that makes it less critical that they're physically proximate. So that's one thing. A lot of what they use is stuff that has been standardized. The second is that today Apple enjoys tremendous market clout. And so when Apple goes to a supplier or somebody who's developing a new technology or device, they have the gravitas to get the attention of this supplier or of this manufacturer. And so I think it's that combination of working with standardized technologies and where they bring in a new disruptive technology, which they do, the ability to command the attention of a supplier base because they have a track record of success at delivering products into very large markets. And so in that respect, I think those combination effects make them a unique entity.
So sort of an outlier in that regard. Yeah. So you mentioned the Kendall Square initiative, and what's going on there? I mean, Kendall Square has had a lot of different lives, and 100 years ago it was a very industrial place, and it sort of has been kind of turned in. Over the time, it became sort of a no man's land. It seems for a while there, and now it's reborn yet again. But what's happening there, and what's MIT's involvement, and how does that play into this study?
Right. Well, I think at a basic level, our involvement is sort of one, our activities compel existing large organizations to want to be near us, and two, reflecting on some of what we talked about earlier, a lot of the translation opportunities right now are through small creation of startups. And having been involved with it, it's, if I'm going to start a company, I'm likely going to start it across the street rather than across the country. And so what you see in Kendall, I think, is the confluence of startups coming out of MIT and large companies that want to be near to MIT in order to get access to people or ideas or both. And so I think as MIT has become more effective, and as particularly the startup path has become a more common path for translation of ideas, you're seeing this increasing density of those sorts of activities in Kendall Square. But you can go back to the 80s and the artificial intelligence revolution, and MIT's significant investments in the development of computer science and the like led to a bunch of AI and software companies in the region in the 70s and 80s. Today, what you see, I think, is in a lot of respects reflective of MIT's, I'll call it, pivot to life sciences, where over the last 20 or 30 years, so much more of our faculty's work is life science, has roots in life science. I mean, you can look at nearly every department in engineering where you've got faculty that are doing biology with an engineering application. That could be mechanical engineering, could be civil engineering. And so this sort of infusion of life sciences into MIT engineering and other places, I think, is then reflective of who's coming to Kendall Square today. In some respects, you could have predicted that this would occur when you go back and recognize that, I forget how many years ago, the faculty of MIT voted to make biology a required subject for all undergraduates. I think it's kind of indicative of that pivot was occurring, and here we have today this huge concentration of biology and life science activities in Kendall Square.
Mm. There's something sort of organic, though, also about the way these things happen. Because it's easy in hindsight to look back at that and sort of trace the evolution of it. But, can you engineer or partly engineer an ecosystem like this, or is it a combination of things?
Yeah, I think it's a mix. So, it starts on, at least in this case, I think it starts on our campus with the leadership and the faculty deciding what are the next great opportunities and basically investing in those opportunities in terms of the campus. Where you can sort of engineer what happens around you is, if you look at MIT and the surrounding areas, a lot of credit goes to the generations of previous leadership of the Institute that had the foresight to acquire the lands that surround MIT. And by acquiring those lands, it gave us an opportunity to have some influence on what happened around us. And one example of that, I think, is the development of these sort of incubators for startups. So if you go back 15, 20 years ago, if you were just focused on developing real estate in Cambridge, you would look for a large company that would lease multiple floors in a building, and then you'd build a building for them. But if somebody came to you and said, hey, why don't you create 500 rooms that are 100 square feet each for 500 startups that don't exist today? No self-respecting real estate agent is going to do that, or developer. But I think MIT, recognizing that that was in fact an interesting opportunity, could use its real estate portfolio to help catalyze that. And so the Cambridge Innovation Center today sits in MIT property, which is owned by our endowment. Recently, we helped participate in the formation of something called Lab Central, which is a new model of incubator for biotech startups. So that's a new thing that's sitting in MIT leased property. So that's where I think you can sort of put your thumb on the scale, which is sort of understanding the science and technology of the Institute and how it's going to move out, using that to inform real estate decisions on the endowment side is where you can make that play.
Mm. And what's been the City of Cambridge's role in this? Because they obviously have been working with MIT on this. It's not a one-sided thing, really.
That's right. So I think we enjoy a really good relationship with the city. It requires a lot of work, and it's more than just the city. You have the leadership of the city. You have the the residents at Cambridge and you have MIT, and trying to come up with solutions which benefit all constituents is a challenge. And I think in rolling out the latest wave of the Kendall initiative, we saw that front and center. So as you started developing these plans and sharing them, various constituents would come forward and express concerns about the amount of housing, or what are you going to do about parking, or what are you going to do about transportation. And I think it required a lot of work between all three parties, but today we have before the city a proposal that I think for the most part and for most participants in the discussion really presents a great opportunity for MIT, a great opportunity for the residents of Cambridge, and a great opportunity for the city.
Right. So where would you say, looking at, the future of MIT, the next 100 years or next few years or 10 years, whatever time period you want to take, where do you see MIT heading?
Yeah, it's a great question, and I think the answer is really in the themes that President Reif has set out for the Institute, where we see ourselves focusing. And, I can sort of tick them off. I mean, one area that we've become very excited and very focused on is education. So MIT with Harvard created edX. We're very focused on the opportunity of using digital learning tools, not only to deliver MIT content and educational materials to a much broader group than just the 4,500 undergraduates in Cambridge, but also to use those capabilities to enhance the way in which we do teach the students here on campus. So education and learning about how people learn, that to us is a really exciting area, and I think you're going to see that as a continued focus area for the Institute and area for growth. We're committed to the importance of basic science and basic research. And this is really important for MIT because I think it's under assault, quite frankly. I think there's a lot of focus on translation and commercialization of research. But we wouldn't be where we are today were it not for the basic research investments that the nation made over the past 20 or 30 years or more. And we have to continue to advocate for the importance of basic research and make sure that at MIT we're providing with the faculty with the resources to do that basic research. And then there's the areas of application like the environment, like energy, like health, where I think we learned a few things. We learned a lot of things in the creation of the energy initiative. And I always like to say that I think one of MIT's competitive advantages is I believe that we are organized very effectively to work across disciplinary boundaries. And I think we see that in the energy initiative, the fact that you can bring together faculty from all 5 schools. And those faculty can put out policy studies that are read in every important office in Washington, D.C. And those faculty can get very focused on important research problems associated with energy. And that the creation of an energy initiative brings philanthropy and brings industries to campus to work together with us. So we learned a lot in doing that, and we think we can do it in environment, we think we can do it in healthcare. And so I think that'll be a focus area. And then the last one touches on something that we've talked about already, which we use the term innovation, but it's really about this intense desire to be more effective and more successful in translating all these great ideas that come out of the people here to impact. And I often use a quote or a figure, which is that if you look at even just 10 years ago, the number of our students when graduating with their bachelor's degree that were going to work for a startup was maybe 1 or 2%. And last year's graduating class, something between 15 or 20%. So we're seeing this very significant shift in the way in which our students are choosing to apply their talents to advance ideas. And the Institute has to be organized to help them be effective as soon as they leave the campus. So focusing on our innovation practices to prepare students and to ease this or to make us more effective in translation of ideas. So I think those are what I see as the focus areas for the Institute for the next decade. And it's a very exciting set of things to do.
A lot to do. Do you see any parallels between, I mean, 100 years ago when the campus was just beginning here and today? I mean, that was obviously, seems to me like a very sort of bold move coming to Cambridge and building this giant campus, really.
Right, right. Well, so, I mean, you're right. And someone once said that, the move from Boston to Cambridge and the move into 1 million square feet of new space was a pretty bold move. And so here we are 100 years later, and cumulatively we're going to add yet again another 1 million square feet of space through the development of Kendall Square. So I think, we're really accelerating the densification, if you will, of this ecosystem around Kendall. And I think that could be very impactful.
Yeah, no doubt. Yeah, yeah. So you've worn so many different hats over the years here, and we've touched on a lot of them, and there probably are others. I mean, it just almost comically, but I mean, it makes me wonder when you sleep, and if you sleep.
I try to.
But what are there things you do outside of MIT that do you have any time to do anything outside of MIT that you enjoy and have time for?
Yeah, next question.
Right.
No, I would think you probably want to ask my wife that question.
What about, I mean, you mentioned growing up a little bit, but I mean, just to return to that, are there moments when you sort of realized, maybe what path you wanted to go on, and or did that come later in life? I mean, as a kid,
Yeah.
up through high school. I mean, were there particular influences or?
Well, I think everybody takes different approaches, and I have colleagues who are very successful, and a lot of their success stems from having to focus on what they wanted to accomplish over a long period of time and pursuing it vigorously. I would say that mine was a lot less deliberative of a path, which is to say that I knew what I enjoyed doing, and I would look for opportunities to do that. And in some respects, MIT has been a great place for me in that regard, because every time I was looking to do something different, there was always something that looked appealing, that mapped onto my interests, and it was just about pursuing that. I don't think it's the right path for everybody, but for me, there was no master plan.
Was there a moment as a kid when you realized, gee, I'm more interested in these kinds of engineering types of things versus something else, or was it just always kind of a natural?
I think it was always natural. I mean, understanding how things were made, making things, was always a fascination of mine, and so it was just logical to kind of have that focus in high school, and then deciding to be an engineering major in college was just sort of a logical thing. And as I said earlier, I think it was just pursuing the things that excited me.
Mm-hmm. Yeah, great. Are there other things that we might touch on at this point? I mean, I'll look through and see if there's anything that I had noted, but about MIT or about your time here. I mean, you've been here a long time, so maybe we could just touch up briefly on sort of how you've seen MIT change in that time, since '81, really, I guess, right?
Yeah. Well, I mean, it's hard to, because my lens on the Institute has changed over the years, but to the extent to which I can keep a common vision, I think one of the things that to me is remarkable about MIT from when I came here in 1981 to today is it has, in some respects, I'll say, grown in stature and impact. And when I look at the students we admit today, the faculty that we hire today, they're extraordinary. And we've just been blessed by ever-increasing caliber people wanting to come to this campus. And I think that speaks volumes about sort of the fundamental tenets of MIT, sort of the fundamental DNA of MIT has stood the test of time and has made us stronger. So I see one thing is just MIT's standing in the world has grown remarkably. And in some respects, what's interesting is it's taken us a while to get comfortable with that. I mean, I think MIT in a lot of ways is a very humble institution. And it surprises me in my role today when people come to us leaders in government, leaders in industry, and want MIT to take a leadership role, and are asking us to do that. And it's not necessarily our natural instinct to do that. And so I think we've grown in stature, and we're trying our ambitions in some respects, and our humility is got to catch up with that.
Yeah, interesting. Yeah, well, lots of opportunity there for sure. Yeah. What? Yeah. So are there other things that come to mind that would be important to talk about, sort of, and also in light of the 100th anniversary of the Cambridge campus, perhaps, or?
No, I think we've touched on most everything I could think of.
Yeah. Yeah. Good. Well, thanks so much for taking the time. I really appreciate it.
My pleasure.